In this example, we'll be solving a right triangle given an angle and a side. Solve right triangle ABC if A is equal to 34 degrees 30 minutes and C is equal to 12.7 inches. And you can see we have the right triangle drawn with angle A 34 degrees 30 minutes and side C 12.7 inches. I've recreated that diagram in a smaller scale. And now we're going to use that information. First, let's find the value of side A since we have angle A. And the way we do that is we say that the sine of angle A would be equal to the side opposite, which is A, divided by the hypotenuse, 12.7. And now we can substitute the angle A, which is 34 degrees, 30 minutes, and that's equal to A divided by 12.7. Converting the 34 degrees, 30 minutes to a decimal and multiplying both sides by the 12.7, we now have that side A would be equal to 12.7 times the sine of 34.5 degrees. Entering sine 34.5 degrees into the calculator gives us the result of 0.564640,624. And now multiplying, and actually that's an approximation, so let me use the approximate symbol. And using the calculator to multiply those two, we come up with an approximate answer of 7.19, and that would be inches. Now, the reason that we rounded off to 7.19 is that that's 3 significant digits, and we're looking at an angle with 3 significant digits as well as the side, which has 3 significant digits, so our answer will. Let's look at now finding side B, and let me bring this clean sheet in so that we have enough room to do that. To do side B, this side, let me add angle A, we will use the cosine because, remember, cosine of angle A would be the side adjacent to A divided by the hypotenuse. And so now we would have cosine of 34 degrees, 30 minutes, is equal to B divided by 12.7. Simplifying here, we would have B is equal to 12.7, multiply both sides by 12.7, and convert the 34 degrees, 30 minutes to 34.5 degrees. Enter all of that information into the calculator, and you'll get an approximate value for B, which is 10.5 inches. The only other information that we need to find in this triangle would be the angle B. And angle B would be equal to 90 degrees minus angle A. So B would be equal to 90 degrees minus 34 degrees, 30 minutes. Of course, we need to borrow here, so the way we show that is to rewrite 90 degrees as 89 degrees, 60 minutes. Now we can subtract the 34 degrees, 30 minutes. That result gives us B is equal to 55 degrees, 30 minutes, and now we've completely solved this right triangle. In this example, we'll be solving a right triangle given 2 sides. Solve right triangle ABC if A equals 29.43 centimeters and C equals 53.58 centimeters. Let's begin this by drawing a sketch of a right triangle and enter the information. Let's call this angle A. We'll call this angle B. That, of course, is angle C. What we know is that side A, which would be the side opposite angle A, is 29.43. Side C, which of course is opposite the right angle, it's the hypotenuse, is 53.58 centimeters. Interestingly enough, what we have is the side opposite A and the hypotenuse. And therefore, we can use the trigonometric function sine of A to find the value of angle A. We know that the sine of angle A would be equal to the ratio of the side opposite divided by the hypotenuse. And so we can substitute 29.43 for the side opposite and substitute 53.58 for the hypotenuse. And then use a calculator that would tell us that the sine of angle A is approximately equal to 0.5492721165. And now we use the inverse sine or sine inverse function of the calculator to say that angle A will equal sine inverse of that same result, so 0.5492721165. The calculator will give us the result that A is approximately equal to 33.32 degrees. So that gives us angle A. Let's now bring in a clean sheet so that I have more room, and we'll do the calculation for angle B. Now, angle B we can find by taking 90 and subtracting angle A. So angle B is equal to 90 degrees minus the result we just found, 33.32 degrees. That gives us that angle B is equal to 56.68 degrees. All we have left to find now is side B. Now, side B, we can use the Pythagorean theorem because we have the two other sides of this right triangle. So we know that B squared would be equal to C squared, the hypotenuse, minus A squared, the other leg, squared. And so B squared would be equal to 53.58 squared minus 29.43 squared. And we'll use a calculator to help us do this. B will be equal to the square root of, and I should put approximately, 2004.6915, and that from a calculator will give us that B is approximately equal to 44.77, and the label is centimeters. So now we've solved the right triangle. In this example, we'll be finding a length when the angle of elevation is known. Shelley McCarthy knows that when she stands 123 feet from the base of a flagpole, the angle of elevation to the top of the flagpole is 26 degrees 40 minutes. If her eyes are 5.30 feet above the ground, find the height of the flagpole. So let's sketch a figure of what's happening here. We'll start with Shelley, my little stick figure, and she is standing 123 feet from the base of a flagpole, but that her eyes are 5.30 feet, and that's feet as well, above the ground. So let me draw the ground here to make that clear. And so now she's looking up at the top of the flagpole. Here's our little flag. And so we know this angle of elevation is 26 degrees, 40 minutes. What we're interested in is the entire length, which is from here down to the base. But I'm going to label just this part of the triangle as a little a. Now what that means is once we find a, we will have to add 5.30 feet to it to find the total height of our flagpole. I've recreated this diagram to a smaller scale, and that's my side A that we're going to solve the triangle for. So what we're going to do is notice that we are looking for the side opposite the angle, and we have the side adjacent to the angle. That should make you automatically think of tangent, because tangent is the opposite over the adjacent. So we have the tangent of 26 degrees, 40 minutes, is equal to the side opposite, which is A, divided by the side adjacent, 123. Let's look at solving this. We will convert this to the decimal degree measure, and we'll multiply both sides by 123. So we'll have A equals 123 times the tangent of 26.6, and it's actually repeating degrees. So in terms of the calculator, we can substitute all that information in. We have A is equal to 123. And now let's use approximate, because we're going to come up with an approximate value for the tangent of 26.6 repeating degrees, and that's 0.50221,888. And finding that product on the calculator, we get approximately 61.8 feet. Remember, though, that that's just the value of A, which is this part of the flagpole. We need to now say that the flagpole is 61.8 feet plus the height of her eyes, her height from her eyes to the ground, 5.30 feet, and therefore the flagpole is, adding those together, 67.1 feet tall. From the top of a 210-foot cliff, David observes a lighthouse that is 430 feet offshore. Find the angle of depression from the top of the cliff to the base of the lighthouse. So let's begin by drawing the cliff, which we know is 210 feet. David observes a lighthouse, so let me draw a lighthouse. Here's the water level, actually. And here's the lighthouse. And the angle of depression is measured against the horizontal. So I'll dash out a horizontal. I'm going to go from the cliff to the base of the lighthouse. And the angle of depression is this angle in here. Let's call that angle B. And what we also know from the information is that the lighthouse is 430 feet from the cliff. So we're interested in this angle B, which is the angle of depression, and when we compare it with this triangle, we'll notice that this is also angle B because we have parallel lines cut by a transversal. And so now what we can say is that the tangent of angle B is equal to the side opposite B divided by the side adjacent to B. So 210 feet divided by 430 feet, and the units cancel. So now we can say that angle B is equal to the inverse tangent of 210 divided by 430. Evaluating this on a calculator, we'll find that angle B, which is the angle of depression, is approximately 26 degrees.